Right, so what we're looking at now is section 2.3 and it's called solving equations. And our goal is I can solve 1 and 2 step equations. So this is a little bit different than what we did before. So first of all, what we've worked with almost exclusively thus far with our algebra section is we've been working with expressions. So a mathematical phrase made up of numbers and variables, and they're connected by operators. And what we mean by operators, adding and subtracting, that really is what it is. So it's a mathematical phrase. And all you can do with these expressions is you can simplify them. There is no equal sign, and that's why all the examples we've had so far has said simplify. So you don't come up with an actual like x equals a number. All you can do is simplify. Now, when we're looking at the difference, however, with an equation is different because it's taking two of those mathematical phrases and putting them together. Okay, putting them together, telling us that they're equal. So if there's an equal sign, then it's a little bit different when we're talking. Okay, so this is what makes it different from the ones above. Okay, so expression, all I can do is simplify. An equation has an equal sign, which means I cannot do a lot more to it. Now, in order to do things to it, we have to follow certain rules. And one of the rules we follow is a thing called inverse operations. So the opposite of adding something is subtracting something. The opposite of multiplying by something is dividing by something. The opposite of squaring something is the square root of something. Okay, so it's important to remember these inverse operations because it's going to help us solve our mathematical equations. Now, lots of stars here. That means what I'm going to show you is really important. And what it is, whatever you do to one side of the equal sign, you must do to the other because it's like a balance, okay? It's a balance. And if I could, I'd make that huge that it would take up the whole screen, which I probably could if I really wanted to. So whatever you do to one side, you must do to the other because that equal sign in math is probably one of the most important fundamental things about mathematics. If something is equal to another thing, okay, very, very important. Okay, so let's look at our examples. So first of all, the first one says solve the following. 4x equals 20. So what I'm after is I want to solve for 1x. I want to know how much 1x is. Now, some of you can do this in your head already, and that's great. However, I need to see what you're doing to both sides. So whatever I write down here is what I need to see on your work and on a test. So right now it says 4 times an x. So the opposite of multiplying, the inverse operation is dividing. So I literally would divide both sides. Now I can divide by doing it like this. Or if you would prefer, you could actually go like this. Now, to be honest with you, I think it's easier, less times I have to pick up my pen if I do it with the stroke underneath. So I'm going to take mine back and do that way again. Okay, but both ways are acceptable. So you have to show them that you're dividing both sides by 4. When I divide both sides by 4, 4 divided by 4 is 1. So I end up with 1x equals, because that canceled out, oops, wanted green, 4 divided by 4 is 1. 1x equals, and 20 divided by 4 is 5. Okay, let's look at the next one. It says x over 3 equals 7. Well, that's the same as x divided by 3 equals 7. Opposite of dividing is multiplying. So what I'm going to do is I'm going to put the multiplying like this. And the reason I did that is the same as the last one. 3 divided by 3 is 1. So I have 1x equals 21. And moving on down to the next question. Okay, this one, it says x minus 5 equals 7. Okay, remember I want to get x by itself. 1x minus 5 equals 7. Why isn't the x by itself? Well, it's a minus 5. Opposite of subtracting 5 would be to add 5 to both sides. Add 5 there, add 5 there. You have to show that step. The 5's cancel out. Negative 5 plus 5 is 0, so I have x equals 7 plus 5, so I have 12. Over to question number 4. 5 plus x equals 2. How do I get rid of that 5? Well, it's a positive 5, so I'm going to subtract 5 on both sides. When I subtract 5 from both sides, I end up with 0 plus x, so I end up with x equals negative 3. And on to the next question. Okay, again, fractions, and you're saying, I hate fractions, I hate them. Too bad, get over it. Okay, 2/3 times x equals 6. I want that 2/3 to disappear. So I can make it disappear. Opposite of multiplying by 2/3 would be to divide by 2/3. Now, when I divide by 2/3, so I have 2/3 right now, and I want to divide by 2/3. So this is why we did that numeracy stuff before. Notice I'm doing it over here. Dividing by a fraction means I multiply by the reciprocal. So I end up with 3 over 2, and I don't know why I have a 5 here. That should have been a 3. And I will make it a 3. Okay, so you end up with 6 over 6, which is 1. Or the 2's cancel out, the 3's cancel out, and you're left with 1. So so what this really means, if I divide by 2/3, is the same as multiplying by 3/2. Dividing by 2/3 is the same as multiplying by 3/2. That's really important. Okay, so I'm going to put it down here. Dividing by 2/3 is the same as multiplying by 3/2. Okay, so if I multiply both sides by 3/2, 3/2 here, which means I must do the same to the other side, 3/2 here. The reason we did that is so for this to cancel out, the 3's are going to cancel, the 2's are going to cancel, and I'm left with x by itself equals. Okay, so 6 times 3/2 is the same as 18 over 2, or 3 times 3, which is going to be 9. Okay, so everything you see right here, and I'm going to use my magic pen, everything you see here, I would need to see on a question. This would be your solution. If you don't give that to me, then you're going to lose major time marks. Let's do another question. We have a few more here. So same kind of thing. 5/4 x equals 40. So multiplying by 5/4 is the same thing as dividing. So the opposite would be dividing by 5/4, which would be the same as multiplying by 4/5. Okay, if you notice, all I did really there was multiply by the reciprocal of that number. Oops, I'm using the magic pen. That won't work because it'll disappear. So I'm multiplying by 4/5 on that side, so I must multiply by 4/5 on this side. And when I do that, the 4/5 and the 5/4 cancel out, and I'm left with 1x equals 36. I believe. Oh, nope, not 36, 32. 32. How did I get that? Well, you can do it a couple different ways. 40 times 4 is 160 divided by 5 is 32, or I could cancel 5 goes into itself once. 5 goes into 40 8 times. 8 times 4 is 32. Next question. 5/7 x equals 32. Notice I'm doing quite a few of these because these are the ones that confuse students. Okay, what's the opposite of multiplying by 5/7 would be multiplying by 7/5 because it would be the same as dividing by 5/7. So do that to both sides. And when I do that, I'm left with 1x equals, and I have quite a mess here. So 32 times 7, so we're looking at 224. And then 1 times 5 is 5. So we can leave it as an improper fraction of 2224 over 5. Okay, so sometimes our answers aren't beautiful. Well, all of the answers are beautiful, but that gives you some kind of idea. Let's go to the next page. Got some more here for us. Okay, so these ones, and I'm going to put the screen up again. Let's take a look at this one. 5x plus 2 equals 22. So the problem is here, I have a few things going on with the x's. I have a 5x that I have to get rid of the 5, and I have a plus 2. So what I'm going to do is I'm going to move my constant terms first. So the opposite of adding 2 is subtracting 2. So I end up with 5x 0 equals 20. So 5x is equal to 20, so now I need to divide both sides by 5 to get rid of the 5. The 5's cancel out to give us 1x. So we have 1x equals 4. And if we look at the next one, it says 5x plus 2x equals 21. Again, I have two terms on the one side, so that means probably something can either go together or I can move it to the other side. While 5x and 2x, those are like terms, so they actually go together. So 5 of them and 2 of them is 7x's equal 21. And then it's just a matter of dividing both sides by 7 to figure out 1x. 7 divided by 7 is 1. And we end up with 1x equals 3. And moving on to our last ones. Okay, the next one. 15 minus 6 equals 3x. Well, obviously the 15 and then minus 6 can go together. So 15 minus 6 is 9. So 9 equals 3x. Now notice what's different here is the x is on the right-hand side. And that's fine. It can stay on the right-hand side. Or if it really bothers you, you can literally flip it around. And you can have 3x equals 9. I'm going to leave it this way because I have no problems with it being there. So divide both sides by 3 in order to get x by itself. 9 divided by 3 is 3. The next one, looks scary, but it's not. Two terms. Those terms either go together or one of them needs to get to the other side. Well, obviously x over 7 doesn't belong with the negative 5, so the first step I'm going to do is I'm going to add 5 to both sides. Okay, when I do that, I end up with x over 7 plus 0 equals 2. And this is dividing by 7, so I'm going to multiply both sides by 7. And I end up with 7's cancel out to give me 1x equals 14. All right, so lots of practice on these. It's going to be a real important skill.